Hello students. Now we discuss the topic that is dissociation constant of acid and base. We know when acids and base weakly dissociated, then there is an equilibrium, ionic equilibrium between undissociated acids and its ions. When the equilibrium is maintained, then this equilibrium constant depends upon the concentration of acids taken and also depends upon the concentration of ions produced in the dissociations. So, what are the relation between dissociation constant and the degree of dissociation and the concentration of H plus and OH minus? Let us discuss. So, we know that one acid is AH. When it dissociates in water, it will produce A minus and H plus. This is the dissociation equation of one monobasic acid having one H, that is monobasic acids. Then if you see the concentration reaction, that equilibrium constant, that is suppose Ka is equal to concentration of A minus into concentration of H plus upon concentration of H. This is the expression of Ka. When H will be A minus and H plus, if AH dissociates into A minus and H plus, let the concentration of initial concentration of H, that is acid, monobasic acid, is C moles per liter, and initially it is zero because no dissociation takes place. Initially AH taken is C moles per liter and A minus is 0, H plus 0. After some time, when the equilibrium is maintained, at the equilibrium stage, then let C alpha is the concentration of H consumed at the particular time at the equilibrium stage. C alpha will consume. What is alpha? Alpha is called degree of dissociation. Alpha is called degree of dissociation. How much? And the maximum value of alpha is 1, and in terms of percentage it is 100%. Concentration is C alpha amount of concentration is consumed, so it will be C alpha produced at the equilibrium. So if you put this value of concentration in the above equation, Ka, dissociation constant of this monobasic acid, will be value of A minus is C alpha into value of H plus also C alpha upon here is how much? C minus C alpha. If you arrange this one, C will be, take the common C will be cancelled, then C alpha square by 1 minus alpha. So this is the derivation of Ka, dissociation constant of monobasic weak acid. Monobasic, why am I telling weak? Without weak, it will not be maintained equilibrium. So if you take strong acids, then it will be dissociated, highly dissociated. So Ka is equal to C alpha square by 1 minus. So Ka is equal to C alpha square by 1 minus alpha. If alpha is very small compared to 1 is the maximum value of alpha, 100% dissociated. When alpha will be very small, then that means very weak acids, then alpha will be very less than 1. Then the above equation Ka is equal to C alpha square by 1, which is equal to C alpha square. Because 1 minus alpha will be 1. Alpha can be neglected in compared to 1. 1 is the maximum value. So K is equal to C alpha square. then what is the value of alpha? Then alpha degree of dissociation is equal to K by C square root. This is the another derivation of degree of dissociation in terms of dissociation constant of acid, and C the concentration of initial concentration of acid. Alpha is the degree of dissociation. What is K? K is called degree, that is the dissociation constant of acid. Similarly, if you take base, then base same, suppose BOH, let it be BOH on dissociation produce B plus and OH minus, same at the equilibrium state. This is the value, it will be C alpha, same dissociation constant of base, that is Kb, monoacidic base, that is called monoacidic base, that will be C alpha square by 1 minus alpha. Same result will come, and this will be equal to C alpha square when alpha is very small in compared to 1. Then Kb also, that means Kb, if you like this, if you write this, that the alpha, here alpha is equal to Kb from C square root. This is another derivation of what? Degree of dissociation of weak base, monoacidic base, that is alpha is equal to Kb. What is Kb? Dissociation constant of base. B means base, A means acid. So this is the relation. Okay. For that is important thing is, if a poly or polybasic acid, or polybasic acid means more than one H plus ion. Let one example A3, AS3 one tribasic acid, so it will produce AH first, AS2 minus and H plus, first step. Then second, again AS2 minus release another H plus, AH, that is AS2 minus plus H plus, again AH2 minus release another H plus, become A3 minus again H plus. Let the dissociation constant of first step is Ka1, second is Ka2, third one is Ka3, because it has three basicity, three H plus ions, step by step, first step, second step, third step, step 1, step 2, step 3. Three step, K1, K2, K2. Already we have read the dissociation constant of this AS3, let it be Ka. For this acid Ka, that we can write like this, that AS3 convert to A3 minus plus 3H plus. For this is suppose Ka. So K is equal to, already we know the characteristic of equilibrium constant. If the reaction is divided into number of steps, then the equilibrium constant, the final equation Ka, for final equation K is equal to how much? It will multiply of each step K1 into K2 into K3. This is very important relation for dissociation constant of particular electrolytes. If we dissociated step by different steps, the relation between dissociation constant of each step and the whole step is equal to be multiplied by, not addition, it will multiply. K is equal to K1, K2, K3. Already we have read the characteristic of equilibrium constant. In the previous previous lesson, if you watch the video, you can see that how the equilibrium constant is divided into number of steps. K is equal to K1, K2, K3. Similarly, if you take base, Kb is equal to Kb1 into Kb2 into Kb3, like this. This is for base. But another important relation is that Ka1 is less than Ka2 less than Ka3 and Kb1 is less than Kb2 less than Kb3. That means when the acid dissociated step by step by releasing H plus ion, the first step, this is the first step. You will see this process is very fast. This is fast. Then it is slow. It is the slowest. Fast step, slow step, slow step. That's why first step means K1 is written wrongly. This is K1 greater than K2. This is Ka2. Similarly, Kb1 greater than Kb3. Okay, K1 greater than K2 greater than K3, Kb1 greater than Kb2, greater than Kb3. This the step is very fast, reaction is very fast. K already we know if the equilibrium constant is greater, larger, then the reaction is faster toward the forward direction. So first step dissociation is faster, second step is slow, then slower, then third step is slowest step. So K1 greater than K2 greater than K3. In comparison of rate constant and dissociation constant. This relation is very important. Another relation we can take, suppose if you take two acid, AH one acid and BH is another acid. Suppose this is your Ka1, another is Ka2. They are dissociation constant. So Ka1 is equal to C alpha square, alpha 1 square. Ka2 is equal to C alpha 2 square. Here the concentration of both acid is same. C. For H acid concentration is C, for BH acid concentration is C. But rate constant is equal to dissociation constant is K1 and for acid, first acid is K1, for second acid is K2. And alpha 1 is the degree of dissociation of first acid, alpha 2 is the degree of dissociation of second acid. Implies that the relation Ka1 upon Ka2 is equal to C is cancelled, alpha 1 square by alpha 2. Implies, this relation also implies that alpha 1 by alpha 2 is equal to square root of K1 by K2. This relation also very important relation, that when two acid will compare with this degree of dissociation and its dissociation constant having same concentration, alpha 1 by alpha 2 is equal to K1 K2. That means alpha 1 degree of dissociation means strength, that is the strength of acid. Alpha 1 means dissociation is fast. If K1 is greater, then automatically alpha 1 will be greater. If K2 is greater, automatically alpha 2 will be greater. So this is the relation between degree of dissociation and its dissociation constant having same concentration is taken. So this is the derivation of dissociation constant of acid and dissociation constant of base. This part also very important. This is for base and this is for acid. Suppose if you take the dissociation constant of water, we will now derive dissociation constant of water. If you calculate dissociation constant of water is also weakest. Water is also one weak electrolyte. It is not highly dissociated. So water maintain one equilibrium with its ions. I is weak, that H plus and OH minus. Water produces H plus ion and OH minus. That's why water is neutral, because H plus, number of H plus, number of OH minus is same in water. That's why water is neutral. So what is the value of K for this? K is equal to H plus ion concentration into OH minus concentration upon water concentration. As water concentration is constant, is fixed, that's why K into water concentration is equal to H plus ion concentration into OH minus concentration. But it has been observed that H plus ion OH minus concentration, this is called Kw. That, what is this? Ionic product of water. This is called, as the water produces H plus ion and OH minus ion, their product is H plus into OH minus. This product concentration is called as ionic product. This is called ionic product of water. Ionic product of water is equal to H plus ion, which is equal to H plus ion into OH minus ion. This ratio. And it has been observed that this ratio, this Kw is equal to H plus into H minus at 25 degrees Celsius. At 25 degrees Celsius, this is equal to 1.0. How much? 1.0 into 10 to the power minus 14. You have to remember, what is the ionic product of water at normal, that is 25 degrees Celsius, is equal to 10 to the power minus 14. It is calculated that for ionic product of water is 10 to the power minus 14 at 25 degrees Celsius. Okay, then you complete this one, then we will proceed the next part. Okay, so that's now Kw is equal to H plus ion concentration into OH minus concentration, which is equal to how much? 10 to the power minus 14 at 25 degree Celsius. Now, let me in water, H plus ion concentration, molar concentration, this bracket means molar concentration is equal to H minus concentration. If put H plus ion concentration in place of HOH minus, right same, is equal to how much? 10 to the power minus 14. Now H plus square is equal to 10 to the power minus 14. That means H plus concentration is equal to 10 to the power minus 7 for water. For pure water means pure water, H plus concentration 10 to the minus 7. If H plus concentration is 10 to the power minus 7, OH minus also same 10 to the power minus 7, because both product is with 10 to the power minus 14. Now if you multiply here, if H plus concentration is equal to 10 to the power minus 7, if you multiply minus log H plus is equal to minus log 10 to the power minus 7. Minus log H plus is represented as pH value, that is called pH, is equal to how much? Minus log 10 to the minus 9, that is 7. So for pure water, the pH is equal to 10 to the power, that is pH is equal to 7. If pH is 7, then OH minus, similarly OH minus concentration is equal to 10 to the power how much? OH minus here also 10 to the power minus 7. If OH minus is equal to, let it be, we can write like in this way. So pH is equal to 7 and H plus is 10 to the power minus 7. And OH minus concentration. This OH minus concentration is how much here? H plus is both is OH minus into H plus, it's put like this, into H plus is equal to how much? 10 to the power minus 14. If you multiply log, minus log OH minus concentration then minus log H plus concentration. If you multiply logarithm, then factor, then it will be, when log is multiplied, log A and B is equal to log A plus log B. This formula is equal to how much? Minus log 10 to the power minus 14. Then this value, minus log OH minus is equal to POH plus minus log H plus is equal to pH. This term is equal to pH and this term is equal to pH. P something means minus log. So this value is equal to 14. That is derivation. So POH and pH of for any solution, the sum of pH and POH is equal to 14. What is pH? Minus log H plus. pH value, already we have read in junior class that pH value, pH and POH of any solution, their summation is equal to how much? 14. Both is 14. So as the solution pH is equal to 7, that is neutral. That is called neutral solution. Neutral solution. For, you can remember this thing, pH is equal to 7 means neutral. pH scale measurement, and pH value less than 7 means acidic, and pH value greater than 7 means basic. This relation also you remember this. And POH is equal to POH plus pH is equal to 14. Okay, so this is a very important relation for the POH and POH relation. And if pH is increasing, then pH will be decreasing. Both, because the summation is 14. And this Kw ionic product is directly proportional to temperature. This is very important. When temperature increases, the ionic product is of water also increases. So generally at 25 degrees Celsius, the pH, that the Kw is equal to 10 to the power minus 14. This is called Kw. That is at condition is at 25 degrees Celsius. This is the fixed value, but when temperature increases, Kw increases. This is the relation you remember. Then we take another, that relation K and Kb. That let it be this formula. The H plus ion concentration of soft drink is 3.8 into 10 to the power minus 3 m. This is the H plus ion concentration of the soft drinks. Soft drinks contain acid. The H plus ion concentration 3 point. Then question is what is the pH? What is the pH? I can calculate. Basically we know answer will be like this. We know pH is equal to minus log H plus concentration. Already we have discussed. Minus log H plus is equal to how much? That is called pH. Minus log H plus is equal to pH. So pH is equal to minus log H plus. And here minus log H plus is how much? 3.8 into 10 to the power minus 3. Then pH will be how much? Minus log 3.8 minus log 10 to the power minus 3. Then it will be minus log 3.8 minus plus 3. That means the pH of solution will be 3 plus 3 minus this much. Approximately you have to calculate the value of logarithm value you have to calculate. Log table you have to use log table. So log 3.8 value you will put, then you will deduct from 3 because minus n. So pH is less than 3. This value means pH will be less than 3. It will be less than 3. Okay. So this is one problem. Another problem is like this. Problem 2. 0.63 nitric acid. 0.63 gram of nitric acid in 100 ml of solution in water. 0.63 gram of nitric acid is present in 100 ml of. What is the pH value? Question is calculate pH value. Okay, this is the question mark. Here you see, for any solution given, we have to calculate its concentration in molarity means moles per liter. So what is the M value? Here molarity, if you calculate, the formula we know already, WB by, because mass term WB by MB into V into 1000. This is the formula we have read in first chapter, that is some basic concept in chemistry. WB by MB into V into 1000. Here WB as per the question is 0.63. And what is the molar mass of nitric acid? Nitric acid molar mass also 63, because 48 plus 1 49, and this is your 20, that is 14, that is 63. This is 63 molar mass, and volume as per the question 100, then 1000. Then answer will be how much you calculate. You calculate this quick. You calculate what is the concentration. What is the concentration of nitric acid? Okay, calculate it. The result is 10 to the power minus 1 m. M means moles per liter. This is the concentration of nitric acid in the given solution. If nitric acid is 10 to the power minus 1, nitric acid contains how many H plus ion? 1 H plus ion. So what is the concentration of H plus ion? It will be 10 to the power minus 1. Because 1 nitric acid contains 1 H plus. So this much of moles of nitric acid contains this much of H plus ion. Because both will be same, because monobasic number of H plus present in nitric acid will be same. So H plus is this much. So what is the pH? pH is equal to minus log H plus ion concentration. Then minus log H plus ion concentration 10 to the power minus 1. The result is 1. So this is the pH value. This is the pH value of 0.60 gram of nitric acid in 100 ml of solution. So when any acid or base is given, then what is the pH value? If you calculate what is the pH and pH, both. If pH is 1, then pH will be this total pH, and already we have read pH and pH is equal to 14. So pH will be 14 minus 1, answer is 13. This is the pH value. pH is 13 and pH is 1, because total summation is 14. So this is regarding the calculation of what? pH calculation and concentration of H plus ion. And what is the concentration of OH minus? If it will ask, OH minus concentration will be, what will the value? If pH is this much, OH minus will be 10 to the power minus 30. Because we know pH is equal to minus log OH minus. If we continue, it will be result will be 10 to the minus 30. pOH that much will be given, then concentration of OH minus will be 10 to the power something. For example, H plus is 10 to the power minus 1, pH is 1. If pH is 1, H plus is 10 to the minus 1. Similarly, if pH is 13, means OH minus 10 to the minus 13. So in this way, you can calculate the value of H plus ion, OH minus ion concentration, and pH value. And in the next class, we'll discuss other type of calculation and that dissociation constant of different types of salt. Okay, thank you all.